sensor, and then there's a color sensor. The color sensor is something new they added last year. In working with the program, I haven't found much difference between them myself. They're just basically detecting different shades of color or different shades of light. We use it mostly for following lines, but in like this game here, we use it to determine the colors. There is, in the programming, you can actually use it to do a light check. In other words, the light at each field is going to be different. You can actually build a program into it, so when you get out, you set it down, and you hit the button, and you can check the light level. And then the robot will know just to follow that light level. So.
And a lot of teams will set it so that they check white and they check black.
Yes.
So you have both ends of the spectrum. Like, I mean, you look at this situation here, there's a little bit of lighting. With one of those robots, if I turn these lights on here, it totally changes the field as to what it looks like, to the robot.
Absolutely. So. Now, something we discovered to get around all of that, to make life easier, is you build a guard around the light that just barely drags along the mat. And so when it's shining its own light out, it's only detecting its own light, and outside light's not going to interfere with it. It saves a whole lot of programming. But if you've got a good programming student, let him go. Let him program it up, man. Go for it. But I like the simple approach of just putting a guard around it. And then you don't want the sensor too close to the ground because it won't allow the light to reflect in. So you want it up enough. And that's why the guard is good, because then you can get it up just the right height. If you get it too high, it's not going to get consistent reading. You got to get it, probably about, somewhere between about a 1/4 inch, 3/16 is about a good depth. But I would have the kids try different ones. If there's a little wrinkle in the map, that can change it. That can change it too. But have them practice. It's a real good thing for them to test and actually make a list up and say, we tested our light sensor, we checked it, we found this level, if we did that and that level, and if they give that to the programming judge and say, this is what we did, the judge is going to love that. They love the detail that the students put into investigating what they're doing. As far as light sensors, it will detect the darkness, the lightness. It has a harder time detecting the colors. Like we have an orange and the green. And I haven't used the color sensor, and I assume that would make a better distinction between those, but I'm not familiar. Have you ever used those color sensors?
Yeah, from what I can understand from the color sensors, it's more about, I think, green, red, and blue.
Okay.
Those are the colors that it senses the best. When you start getting a color like orange or purple that's in the middle,
right,
it struggles with those colors. So I think what the FLL is starting to do is game pieces or elements have those specific colors. So maybe you got to grab the green thing or the red thing or
right,
the blue thing. So that's what I understand from seeing it.
Right, and just actually with the sensors, the programming can deal with that real good. But the light sensor, and these are the light sensors. I don't know if you guys hold on to them or grab them. These things are how do you say it? They're very sensitive. But yet, if you're reading a color and then you go away from the color and it's reading nothing, it almost looks the same to the sensor. You get the same numbers back. So you got to be real careful what you're reading. If you're reading an object, you got to choose whether you want to read the light or the dark, because you got to realize the background. When it gets clear of it and the background comes up, that background is going to be a certain color, and you don't want the color you're using to interfere with it.
Well, that's good. What I would like to draw real quick, like if you have a black line here that's shaded in, imagine that's shaded because I don't want to spend the time to color it all, and you have your light sensor here. This is white, so the value you get, I think, is 0, right? Or is it
0? Yeah, I don't remember. One's high and one's low.
Yeah, so we'll say this is 0. If you were on the entire black area, this would be 1 or 100, let's just say, for simplicity.
Yes.
Well, what happens is when you get here, you don't know what direction you're going, but your number is actually equal to 50, right? Because it's half. And it doesn't matter if you're on this side or you're halfway on this side. This one and this one both equal 50. right? And what a lot of teams will do is when you do a line follow, if you want to try to figure out how to make the robot follow a line, they'll actually have 5 states. So the first state would be keep going straight, don't do anything. And then your middle states is when you're at 50%. So when you're just starting to get off the line, make a small turn. And then you have the 2 outside states, which is when you're no longer seeing anything. Do a hard turn, right? So that makes it so that instead of doing this jerky back and forth, you actually make a more smoother transition as you're driving following. I don't know if that's, you know, too much for people, but you know.
That's exactly what I needed.
Yeah.
Okay, well that helped you.
Yeah.
So there, like I said, there's 5 states, right?
Yeah, and again, the sensors kind of folds in on the programming a little bit too.
0, 50,
So.
100, 50, 0. So this is straight. This is kind of a small turn. Actually, it'd be the other way. A small turn that way, small turn that way. And this one is a hard turn. Hard turn.
And then a lot of programs, what they do is they'll have a block run one wheel.
Well, you can't see that at all.
Yeah. They'll run one drive, and then the other one will be controlled by the light sensor. So it'll be go through a if the Y statement, and it'll select if it's a light color, then go this speed. If it's dark color, go that speed. Okay, so you got these motors. It's driving along, and it's trying to turn left into the dark line. Okay, and it reads the dark line. Oh, it's dark. So then we slow down, and then it drives to the right. When it hits the white line, it says, oh, it's light. Let's go speed up. So that's when he's talking about the zigzag. It's zigzagging down the line, determine whether it's white or black, and it'll just zigzag down. And how fast you make the motors and how wide you make your light zone will depend on how hard it turns. It'll go like this, or it'll be nice and easy. Sometimes you've got a short distance and you want to get the robot there. You don't have the time to nice, wide, smooth distance. So you got the real hard, short, little ones in order to get it right on it. But then if you got a nice long line, then you got a nice smooth one. You can smooth it right into it. And by the time you get to the end of it, you're going real straight. And then that's when you get your T intersection. You can use that as a home plate to start over again. And so the short ones are harder because they're so sharp. Your angle of your robot could be anything. And that throws everything.
When you're reading those values like they're from the sensor.
What's that?
They're reading the 50 to 100 values.
Yeah.
Example. You can get it from the sensor. Okay.
Yes, yes.
Okay.
The program, and when you get into the program, and I hope he shows you, but it has your light value, and you can select either greater than, or less than, or equal to. And then you can select the value and the number, so it's tunable.
And it'll output to the computer what the current value of the sensor is too.
Yes.
So when you set it on the field, like, oh, that's what the sensor of that color is.
Okay.
And you can use multiple sensors. You can actually wire them together. You know how to do that. That's programming. That's wiring them together in the program, not
Right.
physically. Let's go to touch sensor. There isn't much to touch sensors. I mean, a sensor, you push the button and the switch closes and it says the robot, we're there. We actually have one on this robot. It's back here. Little touch sensor when it backs into it. Believe it or not, there's a few more things you can do with that touch sensor. One thing you can do is put a lever on one side with a wheel on it, and sometimes when you're trying to ride along a wall, it tends to wander away. You could use that sensor that if it starts wandering away, it'll open that switch and make it turn back in again. So you can use a touch sensor to help keep it against the wall. I don't know what else you know.
Some of the stuff to remember with the touch sensor is you don't have to touch that small point. You can put extensions
Yes.
on your touch sensor. So you can make a large bumper area. So it's not as fine as what you see in the picture there.
Right.
The other thing is some teams, to start the robot, what they'll do is you have to hit the big green or the big orange button
Yep.
on the top. Well, if it's down in the middle of the belly of the beast and you can't reach it, when you push it, it might shift your robot. So what some people will do is they'll make the touch button what starts the robot. So they'll set that up in their code so it's waiting for that touch sensor to go. And sometimes it's a little bit easier and it's more sensitive than the orange button. So That's some of the different uses people have used them for.
Right. And not to get into programming but too much, but another aspect of that is we put our programs in a My Block. Okay, and then we have all these missions. So we take all those missions and put it into one My Block. So we have all these My Blocks into one My Block, and then there's it waits for you. In other words, you hit the start button and it goes, and it's waiting for you to push a button to go to the next mission. So instead of searching through trying to find all your missions, the mission comes up automatically. And then as he says, you use that touch sensor when it gets to your home base, you set it up, you're ready to go, you hit that touch sensor, goes to the next mission. So you saves time.